Hey, welcome back. Today, I'm going to clear up one of the biggest sources of confusion for anyone starting out in machine learning: the difference between regression and classification. They both sound a bit intimidating at first, but trust me, once you see how they work, you'll be able to pick the right tool for your next project. Let's start with regression. Think of regression as the answer to any question that starts with how much or how many. For example, if I want to predict the price of a house, the answer isn't going to fit neatly into a box labeled expensive or cheap. Instead, it could be $450,000 or $350,250 or any number in between, decimals and all. This is what makes regression powerful. Its output is a continuous value, not just a set of categories. Some classic regression models you'll hear about include linear regression, decision tree regressor, and random forest regressor. They all try to draw that best fit line or curve through your data to make their predictions. Now, how do you know if your regression model is any good? You use metrics like mean squared error or root mean squared error. These basically tell you on average how far off your predictions are from the real answers. Lower error, better model. Alright, let's flip the coin and talk about classification. Classification is all about putting things into buckets or categories. If you're asking which one or what kind, you're in classification territory. Imagine you're building an email filter. You want to know, is this message spam or not spam? There are only two possible answers. Or maybe you're working on an app that identifies animals in photos: cat, dog, or bird. Each photo gets sorted into one of those labeled boxes. Some popular classification models are logistic regression, support vector machines, and decision tree classifier. Notice these are sometimes the same algorithms as regression, but they're tuned to predict categories instead of numbers. To measure how well your classification model is doing, you check metrics like accuracy, precision, and recall. These tell you what percentage of the time your model got the answer right and where it might have made mistakes. And then there's the confusion matrix, a table that literally shows you where your model got confused. So, to sum it all up, regression predicts numbers, classification predicts categories. Both are supervised learning tasks, which means you're training your model with labeled data, whether those labels are numbers or classes. If you remember nothing else, just ask yourself, is my answer a number or a category? That's the key to choosing between regression and classification. Alright, that's it for today. If you found this helpful, don't forget to like and subscribe for more machine learning basics. See you in the next one.